Project 2 by Gina Duff and Ian May. For Project 2, we were assigned to design a shell and tube heat exchanger for cooling the High Performance Computer Center at Michigan State. We were given parameters and certain requirements the heat exchanger was expected to meet, and using those parameters, we arrived at successful and failing heat exchanger designs. The designs we will discuss show where we began and where we ended.
We initially designed our heat exchanger to accommodate a 1 megawatt total heat transfer as is outputted continuously by MSU's HPC. With a 30-degree triangular tube pattern and given parameters, we were met with an error screen. 1 megawatt is too much for a heat exchanger of this size to process. Using the formula Q equals m dot Cp delta T, we found Q to be 0.3 instead of the given 1.0. For m dot, we converted 10 to the 6th gallons per day to kilograms per second. For delta T, we used 30 degrees Fahrenheit as this was the largest change the program would allow. We converted 30 degrees Fahrenheit to Celsius to get delta T to be 16.667 degrees Celsius. Our CP value was the specific heat capacity for water, which is 4.186 kilojoules per kilograms.
Given what we had concluded from the first trial, like Ian said, we used Q equals m dot Cp delta T and found that our heat exchanger maxed out at 0.3 megawatts. So we concluded 3 heat exchangers were needed for a 1 megawatt capacity. Also, after doing some research, we found that a 90 square tube pattern was easier to clean than the 30 triangular, and ease of clean was one of our requirements. It added a little pressure change, but the change was relatively insignificant. The final cost came out to be about $23,200.
Our suggested manufacturer is Modern Metal Processing Incorporated in Williamston, Michigan, who specializes in custom heat exchangers.